Pendyala, who is a professor of transportation systems in the School of Sustainable Engineering in the Built Environment. I think one of the best names for a school ever. At Arizona State. His research focuses on human activity, travel behavior, sustainable mobility strategies, public transportation systems, which most of you know is right up my alley, and the land use, travel, energy, and air quality impacts of a wide range of transportation policies and technologies. Dr. Pendyala has been at Arizona State for a number of years. Before that, he was at the University of South Florida, and he did his work at UC Davis, his master's and PhD work, which most of you know. You know what? I'm ignoring them. That's okay. Which most of you know, we have a number of fans of in the room. So, with no further ado, I'd like to introduce Dr. Ron Pendyala.
Thank you. Very appreciate, Terry, the nice introduction and the warm welcome. Really enjoyed my visit so far, and some very familiar faces. Some of you might know Professor Randy Gensler and I went to graduate school together at grad student offices right across the door, and I believe there might be an unfinished chess match.
I think so. Except for that 1-6 move. Didn't last very long.
So I hope I'm reasonably within the window of the screen here. So I guess what I'm going to talk about is work that we've been doing over several years. Again, as Terry mentioned, I work in the activity travel behavior arena, trying to model human activity travel choices. And what happens in this arena is that there are things we do not observe, and so that's why the title is What We Can't Observe. How do you account for latency, the unobserved in activity travel choice modeling? So in terms of an outline, don't worry about it, I might actually not follow it. So I will just give you the background. If you think about, what we've been doing in the activity travel behavior arena for the past several years, we have made great strides. If you just look at the last decade or two, it has been extremely fertile in terms of advanced simulation-based methods and estimation methods for modeling human activity travel behavior. If you kind of think of the 60s and 70s, which was the golden era of the introduction of the logit models, right, the choice models, so we could do away with diversion curves to determine and to model mode choice behavior, and we can start now bringing theories of consumer choice behavior to actually model how people made mode choices. I think the last decade of what we've seen here now is kind of similar to that era. It kind of reminds you of that very dynamic changes in the fields of modeling human activity travel behavior choices. But if you think about what we can't observe, you probably might remember as kids, if you were scared of the ghosts or something, and you went up to your mom and dad, and they might have told you, well, what you don't see can't hurt you, just go back to bed. And but now you actually know, if you're in the field of transportation, what you don't see can actually hurt you if you don't adequately account for it. So that's what this presentation is all about. So it's really about trying to model human activity travel behavior choices while taking into account these unobserved types of phenomena. And so let me talk about that. If you think about some of the examples of some of these unobserved phenomena, for example, we asked people, what mode of transportation did you use in order to travel to work today? And people report, yes, I drove alone. I have no idea what other modes of transportation you were aware of or you even considered. Right? In order to consider a mode of transportation, you've got to be aware of it first. Aware of its existence, aware of its perhaps service patterns, and so on. So I have no idea as to what is your choice setting. Well, if I'm going to model your choice behavior, I've got to know what your choice set is. And so what's happening is we make assumptions. We just assume that you had drive alone, share a ride, bus, light rail or rail, bike and walk. All of these modes are all in your choice set, and we're happy to do a nice mode choice model and predict travel demand, and we make billion-dollar investments based on those models. And we made a most fundamental assumption that all of these choices, people are aware of them, they actually consider them, and they actually exercise a choice. Okay? Completely erroneous. All right? So, or you're definitely not where you'd like to be when you make that assumption. If you think about another one, behavioral decision-making processes. There's lots of potential activity travel choices which are interrelated. If you think about destination choice, mode choice, you think about what types of activities you want to pursue, how long are those activities, the duration of those activity episodes. There's lots of activity travel choices that are interrelated. But if you think about how these choices are sequenced, so, you know, a classic example we were looking at, you know, a year ago was the linkage between mode choice and trip chaining, right? And we often find that people who drive to work do more trip chaining. They make stops on the way to work, right, the Starbucks effect, and perhaps they make stops on the way back home from work, right, the milk effect. So if you think about making stops, the question is, well, did you choose to drive because you had to trip chain? And it's hard to make those stops if you're taking the bus. Or did you actually make those stops because you were driving and it was convenient to do so? So what's the relationship between mode choice and trip chain?
Can you hear us now?
Yep. Yeah.
Okay.
You can?
Great.
Excellent.
All right. Sorry about that. So I'll repeat everything I said. So essentially we're talking about choice behaviors that we can't observe. So if I just think about the relationship between mode choice and trip chaining, which one comes first? Do you decide about your activity pattern for the day and then say, given this activity pattern, I better drive? Or do you think, you know, I want to drive today, and then, oh, since I'm driving, let me stop and pick up the milk on the way home. So you can think about these different behavioral decision processes that exist in the population, and probably both of these exist. Some people drive because they have to pick up the kids or pick up milk or whatever, and some people perhaps choose to stop because of the convenience the automobile affords. So if you have this diversity of behavioral decision processes in the population, how do you account for that? We don't ask in our surveys, right, which decision affected the other. We just know the range of choices you've made, but we really don't know your behavioral decision-making process. And so our intent, again, is to think about the unobserved. If I'm doing an activity travel demand model for forecasting, I have to make some assumptions about what choice is affecting another choice. All right. So how do you account, or how do you develop models that can, take care of these unobserved behavioral processes? And there's others as well. Those are the two that I'm going to focus on. That's why they're in green. But there are other latent variable, latent constructs in the choice modeling field that I'm just not going to cover, but that is a very fertile area if you're looking for a master's or a doctoral thesis topic. But the notion of latency, it's been around. So this has been recognized in the literature. There's been considerable work in the travel behavior field, including some of the work we've done. Structural equations modeling methods have always tried to incorporate latent dependent variables. In some cases, we actually consider factor analysis to be constructing latent variables based on a lot of attitudinal variables and so on that people provide as part of surveys. And there's also efforts to do latent market segmentation. So that is trying to identify homogeneous groups in the population that perhaps follow certain patterns. Again, you kind of tease that out of the survey data without explicitly asking people to give you that information. And so that's some of what we're going to try. So the idea is we like to capture the behavioral heterogeneity, the variance you see in the population using these latent constructs. Okay, so here's kind of the first example, the latency in choice set formation. And again, we talked about, you know, we have no idea what you're aware of and which modes of transportation you consider. So people may not be aware of all the possible alternatives when making a choice. Even if they are aware of an alternative, it doesn't mean that they necessarily consider it, right, when they're exercising their choice. So just being aware of it doesn't necessarily mean that it's in your choice set. But you've got to be aware of it if it's going to appear. So surveys do not include questions about awareness and consideration until actually a recent TCRP, Transit Corporate Research Program, project that is going on now in which I'm involved. And as part of this transit project, we did a survey and we explicitly asked people about their awareness of transit modes, and if they are aware, did they actually consider using it? And so it's given us some very valuable data. Oh, in fact, this table is out of that PCRP project. We've completed an interim report. So it essentially, you know, kind of gives information about this is only the consideration. Well, not available is kind of a pseudo term for not aware, right? So if the respondent says that transit's not available, that may be simply because the respondent's not aware of it, even though it kind of passes right in front of their, you know, their front door. They just don't pay attention. So we consider that as not available, and you can see that's a very high number. That's literally half of the sample says transit's not even available, let alone considering it. And yet our mode choice models consistently have transit in the choice set, right? Even though half here say it's not available, and this is trained. This is actually in Charlotte, North Carolina. So they have obviously a very small light rail line. So it's not that surprising that a lot of folks consider train to be not available. But then you can see among those who consider, what is the ratio of those who choose to take the transit mode versus those who choose not to take it. This is a 50-50 split. So in other words, among those who consider transit mode share is 50%. Not bad at all. So kind of opens your eyes to how mode choice works once you start thinking about consideration versus availability and awareness. So the example I'm going to be looking at, in this presentation is choice set formation, right? Determining that latent choice set in the context of non-work activity participation. And we're looking at non-work activity participation for workers. So if you think about workers, they can undertake non-work activities in different periods of the day, right? So if you're a worker, you're a commuter, or even a student who has classes and so on, you can undertake your non-work activities kind of around your work and school schedules. Right? You can do it on your way home, you can do it before work, you can do it after work, right? There's different periods of the day in which you can do this. So if I was trying to construct a daily activity schedule for a worker, I would need to know where this worker is going to place the non-work activities in that schedule, right? So I first determine the work episodes, and now I want to place these non-work episodes. And the question is, if a worker has 5 different time slots in which they can place a non-work activity, are they going to consider all 5 time slots? Are all 5 time periods in the choice set? Perhaps not. Right? So that's kind of the question. Now, why the focus on non-work activities in travel? Simply because non-work activities in travel are gaining a lot of importance. They probably account for more than 80% of all travel demand. Work travel is really only about 15 to 20% of all travel. So, given the importance of non-work activity travel demand and the large variance you see with non-work activity travel patterns, there's a lot of interest in trying to be able to model it more effectively. So this is what we have in terms of a schedule, right? So you can think about 5 periods when you can do non-work activities. I can schedule those activities before work, during the home to work journey, right? You make a stop on the way to work, while at work, so you can, just while at work, make a work-based trip, during the work to home journey, or after returning home. So this is the after work period. So that is you return home, and then you make a separate trip to go to the gym or store or whatever. So when can workers perform these non-work activities? Now, unlike the single discrete problem, this is a multiple discrete problem, because you could literally do multiple activities in multiple time periods. Right? It's not like you're limited to doing a non-work activity in just a single time period, right? You can do it twice or thrice, throughout the day. So multiple time periods, so this is a multiple discrete problem. Now, if you already learned the multinomial logit model, that's a single discrete choice model, right? You can choose only one alternative out of the choice set. How do you model a situation where you can choose multiple alternatives? And at the same time, also account for the fact that an individual may not have all 5 time periods in their choice set. Okay? So the choice set may vary from individual to individual. Some people may have all 5 time periods, but others may have fewer. Okay? So these are the kinds of models we're trying to introduce in a lot of our activity travel demand forecasting model systems, so that we're trying to more accurately model behavior. So workers may choose none, one, or multiple time periods in which to pursue non-work activities. Again, there's a lot of interest simply because location choice may be discretionary in nature. There's a continuous dependent variable. So in addition to modeling the scheduling of these non-work activities, we're also modeling simultaneously mileage. How far do you travel for these non-work activities? And we obviously are very interested in mileage simply from an energy and emission standpoint. Okay? So we have that continuous dependent variable combined with a multiple discrete dependent variable, right? Choosing multiple time periods to schedule your activities in travel. So simultaneously model choice of time periods and the mileage. So this leads to the multiple discrete continuous problem. And my very good friend and collaborator, Professor Chandra Bhatt, at the University of Texas at Austin, with whom I work very closely, has essentially solved this multiple discrete continuous problem. I think one of the major landmark developments in choice modeling of the past decade or two. So, but the time period choice set, again, is not known. We do recognize it varies across the population, but it's not explicitly observed or reported. So you need to model the choice set formation in a non-compensatory way, and then model the choice process itself in a compensatory way. So compensatory behavior is where you trade off, one choice versus the other, right? In terms of their attributes, so which one is better, which one is not better, so you kind of compensate across choice alternatives. But just to include, choice alternatives in the choice set, do you need to necessarily use compensatory choice behavior theory? Probably not. You can probably just include alternatives in the choice set as long as they meet a certain threshold. If it's good enough, it's going to be in the choice set. And that's kind of the approach we take here. Right? So if your utility of an alternative is of a certain minimum value, If you reach a minimum utility threshold, it's in the choice set. Okay? And then you trade off across the alternatives when you actually make the choice. Okay? So there's a two-stage model with a probabilistic choice set generation, followed by a probabilistic choice model itself. Okay? The probabilistic choice set generation is combined with the multiple discrete continuous extreme value model, so the MDCEV, which again has really opened up lots of opportunities to model multiple discrete situations. We adopt a random constraint-based approach, which was by Swade and Benakiva in '87, when they were trying to talk about choice set generation. How do you generate choice sets more accurately? And the alternative is included in the choice set if you have a utility that's above a minimum threshold value. That's essentially what you have. Okay, so this is the probability that alternative I is considered by individual Q. Okay, so very simple, similar to a logit formulation, right? So this is the probability that an alternative is going to be in the choice set. Okay, where you have just explanatory variables of the individual, their work characteristics, and so on, affecting whether the choice alternative is in the choice set, and you have to estimate a coefficient vector. So that's a function of sociodemographic and built environment. Okay, and then so the probability of a choice set emerging, okay, for an individual Q. So the probability of a choice set C being in existence for an individual Q is essentially this term or this formulation here, right? Essentially, it is this probability of each alternative being included in the choice set. So the product of that will give you the joint probability of multiple choices being in the choice set, except I have to do a normalization to remove the choice set that has no alternatives. Okay, so we just account for that zero-member choice set. Okay, but that's the probability of a choice set for individual Q. And the second stage, we have the multiple discrete continuous extreme value model. This is simply representing the probability of individual Q making one or more choices given the choice set C. Right? So you have a choice set C, right? So now it's the probability, choice of one or more alternatives, PQ given C, probability of making a choice or one or more choices given that choice set. That's given by this formulation. It's right out of the basic MDCEV model formulation, right, for the probability form. Okay? So I won't necessarily go into details, except to say that as part of that, we do model the mileage. Okay? So the DI star is the mileage corresponding to an alternative. There are some parameters that we introduce, gamma and alpha. And those parameters are satiation parameters, okay? And the satiation parameters are basically accounting for the fact that too much of anything is probably not good for you. So, even if you're eating a lot of cake, after a while, enough is enough. So, these satiation parameters just account for the fact that after a while, you're ready to move on. Right? So you want to terminate the activity and you want to just go do something else. So that's what those satiation. You are satisfied and ready to go. And then we estimate a vector of coefficients. So this model formulation takes into account several behavioral aspects. This is the bottom line. Okay? You have a probability for an individual Q is simply the product, right, of that individual Q choosing one or more alternatives from a choice set given the feasible choice set C times the probability of that choice set emerging for the individual, right? A very basic formulation. Prior to this slide, I simply showed you the form of this probability function and the form of that probability function. That's all I did. So a very nice, straightforward application of a latent choice set generation model with a multiple discrete continuous extreme value model. We use the NHTS data that I think many might be aware of, the 2009 National Household Travel Survey data. Of course, it has 150,000 plus households, 320,000 plus persons. We don't want to deal with such large samples for our model estimation efforts, so we really can control the sample that we're dealing with. In some of our previous work, we've put together extensive land use data for the San Francisco Bay Area. So we extracted the San Francisco Bay Area sample so we could integrate some land use measures and built environment measures into the sample data set. We looked at employed individuals because this is non-work activity scheduling for workers. So we're looking at workers aged 18 plus years who reported travel on weekdays. So we had a final estimation sample of about 1,000 plus persons, much nicer for a model estimation of this nature. And non-work activities were coded into these 5 time of day periods. Mileage also was calculated for 3 modes, auto, transit, and non-motorized. So you really had a total of 15 alternatives, 5 times 3, the 5 time of day periods times the 3 modes of transportation. Okay. Here's some sample characteristics. Nothing too unusual for a exclusive worker sample, right? So it's not representative of the general population. Slightly higher on the females. Interestingly, we had quite a high percentage that reported no non-work activities. So 31% just went to work hard, and went back home. So they just didn't do non-work activities. Individuals more than 50 years, so slightly older sample, again because it's kind of a exclusive worker sample. 67% in households with 2 adults, 56% actually had no children, again maybe representing the slightly older age nature of the sample. A very high income group, but again this is San Francisco Bay Area, so maybe you can moderate that income number a bit. So this is non-work activity engagement. I think all I wanted to really point out here is how you see larger percentages of people performing their non-work activities kind of in the after-work time periods. So you'll see smaller percentages pursue non-work activities in the early part of the day, but after work, everybody's trying, a lot of people are trying to do other stuff as well. So you'll kind of see these higher percentage of non-work activity engagement after work. And then you see the non-auto tour as well. We just calculated that separately. So the latent choice set MDCEV model. So we took 2 model forms. The latent choice MDCEV model that takes into account the choice set formation. And we did the pure MDCEV. That is, I assume 5 time periods are in everybody's choice set. Okay, the pure MDCEV, ignoring the choice set formation model. All right, and there's some key differences that we found between these 2, clearly suggesting that the latent choice set generation model really added a lot of value in modeling this choice process. Okay, so variable significant in the latent choice came out insignificant in the pure MDCEV model. Coefficient parameters in the pure MDCEV model were inflated in comparison to the coefficients in the latent choice set MDCEV model. So it looks like the coefficients you're getting from the pure MDCEV is kind of a mixture of the effects. Right? These coefficients are accounting for the choice set generation process as well as the actual choice process. And you're not able to separate those 2 effects. Okay? So your socio-demographic characteristics affect both of these phenomena. Affect both whether an alternative is in your choice set and affects whether you are going to actually choose it. Right? And if you do the pure MDCEV, you're not being able to separate those 2 effects. Okay? So again, this latent choice set MDCEV offered a lot for us to be able to more accurately reflect these behavioral processes. Okay. So these were some of the variables that impacted these choice processes. So very behaviorally intuitive results. I'm not going to present these massive tables with coefficients and p-statistics. They're just a blur. So, but essentially, just trust me, the models look good, and the p-statistics were all wonderful. So we were very happy with the way the models came out. Okay. Oh, I actually do give you at least goodness of fit statistics, and that wonderful asterisk there means it is better than the others. So if you look at the latent MDCEV, big difference in the likelihood at convergence, big difference in the adjusted likelihood ratio index, and again a big difference in the Bayesian information criterion. Smaller the better with the BIC. Okay, so again, just big differences. All right. Decision paradigms. So let's see. How much time do I have?
Maybe 5 more minutes and then questions?
Okay,
Okay?
that is just wonderful. I am very adaptable.
Okay.
So this was the second one, and here I'm just going to present the idea. That way I can skip over most of the slides. They just shoot you bullet by bullet. So basically the idea is, if you think about households make some long-term location choice decisions. Residential location, where to live, and workers in the household have to think about where to live, right? The job location choice. And of course, it's not like you can choose any job location, you've got to get the job. But you can target your job location search, perhaps based on your residential location, or vice versa. You can target your residential location search based on where you found work, right? And if you think about this bi-directional process, right, there's probably some households or some workers who chose a residential location based on their work location, and there's probably other households and workers who chose their, I don't know which one I just said, but who chose their residential location based on their work location. If you actually look at the literature, it's dominated by the assumption that residential location choice is affected by work location choice. Okay, that people try to, have a work location and then try to perhaps optimize or kind of look at their commuting times and find a residential location choice given the work location choice. But does that really apply to everybody? The population is likely to be very heterogeneous. You're very likely to have people who are in fact finding a work location choice based on where they live. So it's convenient. And so we wanted to be able to come up with a model system that relates residential and workplace location choices while accommodating both causal structures. But I have no idea who is adopting one causal structure versus the other. So I've got to use a latent construct, right? This is the unobserved decision structure that's existing in the population. I need to use a latent construct in order to segment my population. Here's the group of households who did residential location choice affecting work location choice, and here's the group of households for whom work location choice affected residential location choice. Okay? So that's basically what this work was about, was trying to come up with the latent decision structure that prevails in the population. Okay? So two major long-term location choices, household and work location choice. You can have which one comes first. Okay? And I do recognize it is a cyclical relationship perhaps, but you can still think about situations, or basically these two directional situations, one affecting the other or the opposite, and you have both prevalent in the population. I just need to know how to segment the population and identify households that belong to each causal structure. Okay? That's what we're after. Okay? So in a behaviorally heterogeneous population, both mechanisms likely to exist. Okay? This is right out of the paper that we had with Professor Paul Waddell, again Chandra Butt, myself, This was, again, in our trying to do some integrated land use transport modeling. We did this paper on interdependent household location and work location choices. This is a quote that essentially ends with the words, if you don't account for this heterogeneity, you are distorting the policy evaluation of transportation investments or land use regulations. Okay, a pretty powerful statement. So hopefully I've convinced you that what we did was valuable. So here's residential work location choices. We don't know. Another big problem with this residential work location choice problem, if you have 1,000 locations, and I had to exhaustively enumerate all possible combinations, that's 1,000,000 choices, right? 1,000 residence work location combinations times 1,000, so it's 1,000,000. So this becomes an exploding choice set problem as well. Okay, so that just talks about the exploding choice set problem. I've convinced you of that. The model formulation here is rather extensive, okay, so I will skip over this. But this is, again, we're just looking at these two segments. Probability of choosing a work location given a residence location, okay? And you can kind of, you can integrate that function in order to get the unconditional probability, okay? So not an issue there. So just to construct the likelihood function, okay, for model estimation. Here's the other way around. Probability of residence location given workplace, okay? So this is the other population segment. You can, again, integrate that out as well, right? Then you actually need the probability of your falling into one of the other segments, okay? Which causal structure do you adopt, okay? So that is this. If you fall into the probability of residence first, so the probability you're in the other segment is 1 minus of that, okay? And you can then just multiply this out to get the probability for the entire choice process. So the probability that you are choosing a residence location, workplace location combination, IK is a residence workplace combination, okay, is given simply by this formulation. Pretty straightforward probability formulation that you can just write out. That gives you a likelihood function that you can maximize, estimate parameters, and be very happy. So it's quite straightforward. I wanted to end this with, so we have different equations and model specifications. We use different types of variables. We had 900 traffic analysis zone situations. So if we had to do the classic model, it would be 900 times 900, which is quite formidable, even with simple multinomial logit. But then you have all kinds of other problems with the multinomial logit. Okay, so we used a data set that's a little dated now, but at the time it was reasonably good, and it had lots of land use variables appended to it. So that's why it was perfect for location choice modeling. And the final sample had about 1823 households. We tried to simplify the problem by considering one worker households, because once you start having multiple worker households, that's a whole nother level of complexity with multiple workers optimizing residence work location choice decisions. So we went with the one worker households. We estimated different types of models. The joint model, right, where you had both of these latent segments prevalent in the population, provided superior goodness of fit, and so indicating we had benefit. What I wanted to leave you with is the fact that the findings were quite counter to what we started off with. We had assumed that a vast majority would have the work location is given and residence location is based on work location. Completely the opposite. We have 81% of the households falling into the category where the residential location is given and drives the work location choice. We're still struggling with this one, I will say. But it was just fascinating enough, I just had to share it with you. So it's here. And you know, I mean, it is interesting. And indeed, in some of our panel data, we do find people changing jobs more often than they change home locations. And And so perhaps this is really reflecting that job mobility, whereas you have a fixed home location. So, and then we did have some other interesting findings as well, that there's more dispersion in the residential choice-making process as opposed to the workplace work location choice-making process, which is also kind of interesting as well. There may be more degrees of freedom with residential choice than with work location choice. Okay, here we had some elasticity computations showing what was your sensitivity to falling into one group or the other in terms of that behavioral structure, in response to socio-demographic characteristics. So we found that actually, depending on your life cycle, income, and so on, that affected which behavioral decision structure you tended to adopt. So implications and conclusions. Just wanted to note again, we believe these latent constructs offer a lot in terms of being able to model activity travel choice behavior and in being able to come up with more accurate forecasts, land use forecasts, right, as well as travel forecasts, say even in the mode choice context when you're doing light rail investment studies or any mode choice type of studies. We find substantial difference between models that ignore versus those that use latent constructs. So, we're trying to further document some of the policy implications of these models and think about the implications for data collection efforts. So we're actually trying to convince some of the MPOs and so on, including Southern California, where we're doing their activity-based travel model, that in their next household travel survey, they should include questions that try to get at some of these latent things, or include questions about awareness consideration, which choice affected the other, right? Trying to get that kind of information. So with that, I thank you very much.
So I think we have a few minutes at least. The classroom, there's a class starting at 1:05, but maybe let's take 5 minutes for questions, just so we have an opportunity.
This second paper, the Waddell paper that you presented on, I've read that paper quite closely and was very interested in it. And we thought that we were going to get access to the RDC, the Census Remote Data Center, that would answer some really great questions that could continue that work. That is not happening, but I was wondering, what if you had your choice? Like, what would be your next step with that research?
That is a good. I think really we would want to just be able to collect more in-depth data from individuals directly, and be able to find out perhaps which decision might have affected the other. But more importantly, I think. If we can start using more longitudinal data or panel data, that kind of gives us a sense of how people are changing their location choices, and you can kind of relate that to changes in their either the built environment or changes in household structure and composition over time, or their work situations over time. I think that can give us a lot. So, if you think about residential and workplace location choice connection, the time dimension is a natural component of it, because all location choices have a lag, right? If you're responding to a change in job, it will take you some time to make a residential location choice. So I think that work was very cross-sectional in nature, and I think we teased it out pretty well, but I would like to just be able to explicitly incorporate the time dimension by using longitudinal data.
Yeah, kind of along those lines, I think it was interesting that 1999 showed such a strong, the 81%.
Right.
As it was a more booming economy, I'd be interested, do you have plans on maybe if 2009 data probably would be relevant?
Right, yeah, and we do have data. It always takes a little bit of work in order to create what I call this comprehensive data set with all of the built environment variables appended to a travel survey data set. So, but yeah, indeed, I mean, in different economic times, when you don't have perhaps a choice of a job location, you got to take whatever job is out there. What are the implications? Perhaps then work location does affect home location more than what we've found.
Plus, we have tons of people that can't move now because they're upside down in their,
Oh,
in
but
their
there's
mortgages.
others, yeah, no, that's a good point too, yeah. So that could be an opposite force,
Yeah.
right? Yeah.
Kind of along those lines, did you look at that in terms of like, say, renters versus owners?
So,
Did you look at that job mobility versus residence mobility in terms of maybe renters versus owners?
yeah, so I think renter versus owner is definitely an explanatory variable in the model. So it is there, it is significant in terms of which decision structure you fall in. So indeed, we found home ownership to be a rather significant variable in positively placing people into the 81%. Right? Yes.
Is school considered?
Oh, so school location, yes, yes. So we have some neighborhood attributes that speak to the school quality in that area. And so school quality, we found to again be a very strong predictor of that 81%. A lot of people, once they choose a good school district, they do not want to get out of there. So we found some of those very strong anchors that keep people in place.
What about, I think this is another question related to the other ones. What about the substitutability of the job? You know, some people may have highly substitutable jobs, and others,
Right.
you know, for instance, you have to teach at a university, and other people, even at your same income level, may be able to switch jobs more regularly.
You know, I will say, if you look at the two models in that paper that you read, the residence location model has a far richer specification than the workplace location choice model, simply because in the workplace location choice, we just don't have a lot of rich information about the workplace location, the job, the occupation, type of work, and so on. So I do think that model can use a richer specification. So that's a good point. I forget whether we actually had occupation type as an explanatory variable, but I would think it greatly affect your ability to adapt workplace.
Okay. Let's thank Dr.